Welcome to Maths Clinic series. In this video, we are continuing the topic plane geometry. And this aspect we are going to deal with angles. And these are objectives. By the end of this video, you should be able to define what an angle is, to identify and explain the difference between or different types of angles, explain the meaning of complementary and supplementary angles, define adjacent angles, then name angles. So these are some of the things we are going to look at, and I'm praying that by the time I finish, you should be able to do all these steps. What is an angle? Normally you hear students saying angle is formed when two or more lines meet at a point. Well, there's a slight error in that definition, and we'll look at it very soon. Now, angles are formed, not angle is formed. That's the first thing you have to take note of. Angles are formed when two or more straight lines meet at a point called vectors. I'm saying not S, because the moment two lines meet, we don't have one angle formed. We have more than an angle formed. So here I can have one angle here, and I can also have another angle there. So I can have here an acute angle and reflex angle. So anytime two or more straight lines meet, we get not only one angle but more than one. So here I have two or more straight lines, so four angles has been formed here. And so it's better we say angles are formed when two or more straight lines. And I'm talking about straight lines simply means they must be straight. If I have a curve and a straight line, we don't have an angle. Whatever space is there will not be an angle. Probably it might be a sector or something. But angles are formed when two straight or more lines meet. So again, in some other definition, you can also say that angle is a shape formed by two straight lines or rays diverging from a common point called vectors. And so here I diverge two lines from a common point, and so we can have the vectors created and we have an angle formed. So we have an angle formed here, an angle formed there as well. There are a lot of definitions that has to do with angles, so you can go for more definition by researching to that. So we can see angle here, angle there. In real life situation, we see angles. Even in our arms, we see angles. In our physical body, we see a lot of angles. In structures, we see angles. In buildings, there are a lot of angles in so many forms. And so angles can be located in all places. Right. Even on our roads, angles are created. Can you see that? In planes, you can see angles. Right. So there are lots of angles that we can see everywhere. Now, measurement of angles. Measurement of angles. How do we measure angles? Angles are measured using instrument called a protractor. Now, the video number 3 after this video is a video that has to do with how to use protractor in measuring angles, which I will recommend that you watch that video before you proceed to the video number 4, so that you will understand how to measure angles using protractor. It's very important because you need it in dealing with constructions, what do you call circle theorem and the rest. But for now, we want to just look at the fact that how we can name angles and then the rest. So angles are measured using an instrument called protractor, and you can see protractor here. Detail has been done in video number 3. Angles are measured in degrees. Example, 90 degrees, 30 degrees, 1 degree, 2 degrees, and so on and so forth. Angles are also measured in radians. And for elective math students, they understand more about this radians in trigonometry. They study more about that. Example can be 2 pi radian, pi on 2 radian, pi on 6 radian, and so on and so forth. And also, let me also mention that apart from the angles in degrees and radians, normally we also measure angles in minutes and seconds. So if I give you, let's say 28.3, I can say 28.3 degrees, which of course in real life situation you can say that is 28 degrees 3 minutes. And the next value that comes after the decimal point again will be in seconds, and so on and so forth. Now I want to look at types of angles. And we use GeoGebra to demonstrate this before we look at the note aspect of it. So with types of angles, we want to use this to demonstrate types of angles. So you can see that I have 2 points or 3 points here, A prime, A, and then B. Right, so now the red line and the blue line meet at a point B, and then they create an angle between them, which of course we can also think about the angle outside. For now, I just want us to look at the one inside the two lines, right? So for now, the angle between them, let's say, is 0. So you can see 0 from the reading here, 0. Now when I move it to, let's say, angle 1 or 2, I create a very small space in between them. That is, the theta over here is or the upper is a small angle called 2 degrees. So I can increase this angle to 48. I can continue it on and on and on and on up to 360 there to end again. Now we are saying that when the angle that exists between the two lines is, let's say, 34 degrees or 1 degree or 2 degrees, or all these angles, before it hits 90 degrees, anything less than 90, 78, 60 degrees, 30 degrees, 20 degrees, they are all called acute angles. So angle of 30 is acute angle, angle of 20 is acute angle, angle of 1 degree is an acute angle, angle of 89.99999 is an acute angle. So that is the first type of angle we call acute angle. Now when this thing travels and hits exactly on 90 degrees, then we give it a new name, and this 90 degrees is called right angle. So when it hits 90, we call it right angle. So this is right angle. So before it hit 90 is acute. When it hit 90, then it becomes right angle. When it travels a little bit above 90, then it's given a new name called obtuse. So all these angles are obtuse. Before it gets to 180, it's called obtuse. So 178 is obtuse, 92 is obtuse, 171 is obtuse. You can see that 108 is obtuse. So look at the size of obtuse. Look at where the green line is. That is the size of obtuse. Okay, good. Now the moment it hits 180 exactly, they will give it a new name. We call it straight angle. Straight angle. So straight angle is an angle of 180 degrees. When it travels a little beyond 180 or far beyond 180, then all those angles before it hit 360 are called reflex angles. And so angle of 196 degrees is a reflex angle. Angle of 232 degrees is a reflex angle. Angle of 318 is a reflex angle, and it goes on and on until we hit 360. But when we hit 360, we don't call it reflex angle again. It becomes a one revolution, so, or a revolution for that matter. It has no just an angle of 360. We can't call it reflex angle, right? It's more or less like it has come back to its original position. Good. So these are the 5 different types of angles that I can explain to you for now. So types of angles has been explained, and we said acute angle. So you can pause the video and write some things down for yourself, right? So it's acute angle, and the definition is as such. These are real life situations of examples of acute. You can see acute here, acute angle here, acute angle there. Then we came to right angle, and the definition says that it's an angle formed by 2 perpendicular lines, or when 2 lines meet at 90, we have right angle. So all these are examples of right angles. And this is a typical example. When we have a vertical and then a horizontal, they always meet at right angle. Then we talk of obtuse angle. And the definition of obtuse angle is here. An example of obtuse angle. In real life situation, you can see it in so many places. Then we talk of straight angle. This is straight angle is an angle of 180 degrees. Now, let me point something to you quickly. When I draw a line segment like this, we can't say this line has got a straight angle of 180. It's not true, because it's just a line. There is no meeting point of two or more lines, so there's no angle. But when I locate a point in the middle here, then I'm trying to have two line segments. One starting from here, it ends here. Another one starts from here, it ends there. And so if I put, let's say, a point here and call it point A, then I'm thinking of having a line maybe BA and then the line AC. For that matter, now they meet here and then the angle of 180 will be as such. Then we talk of reflex angle. That is the definition. Now, this is what we have to now look at. There's another term we have to understand as far as angles are concerned. We have what we call complementary angle. Complementary angle. Now, per the definition, we are saying that when two angles are complementary, or sorry, two angles are complementary if they sum up to 90 degrees. So if I have a value 33 degrees and another value of an angle called 57 degrees, and these two, when I add them, I'm going to get 90 degrees, then I'll call the two angles supplementary. So 72 and 18 are complementary. 1 and 89 degrees are complementary. 2 degrees and 88 degrees are complementary. If I have right angle triangle, automatically the two other angles which are not right are complementary. Those sum up to 180. And so if I have these two angles which are adjacent, we'll talk about that very soon. These two adjacent angles sum up to 90. They will call them complementary angles. Then there's another word you need to understand called supplementary angle. By the definition, when two angles are supplementary, they add up to 180. So if I have 60 and 120, I can add them up to give you 180. That means 60 is supplementary to 120, or 120 is supplementary to 60. 82 and 98 will add up to give you 180. For that matter, these two angles are supplementary. If I have this diagram, if this diagram we see we have a straight line with another line meeting at a point, we see that since these two angles will add up to 180, we will say they are supplementary. And we normally use the word two angles on a straight line, so to add up to 180. Now if I have a parallelogram, two consecutive angles are always supplementary. And so if I have this angle A, angle B, we can say they are supplementary. Now this particular idea is for parallelograms. Okay, if it is trapezium or kite, it doesn't work that way, right? So it works for parallelogram like rectangles, rhombus, and the rest. I mean, the parallelogram family has this particular property. In circle theorem, you also realize that if I give you this theorem whereby we have an angle subtended by a chord AB to the center and circumference, we normally say they are supplementary. Sorry, I made a mistake with the diagram. It should rather be a diagram of this sort where we have two angles subtended by the same chord in opposite segments. We normally say they are supplementary, which means they will add up to give you 180. So there are lots of applications of supplementary angles as far as plane geometry is concerned. Now let's look at let me call it maybe the last but one aspect of angles, called adjacent angles. Now, two angles are adjacent if they share the same vectors and have one side in common between them. So we can see these two angles, they are on the same straight line, they share the same vectors. So since they all meet at this very point, they will say these two angles are adjacent, meaning that they have only one line between them. That makes them adjacent. And normally we say adjacent angles on a straight line are supplement, so they add up to 180. Not that they are supplementary, because it can be more than two. Now if you look at this other two diagrams here, we still see two angles which are adjacent. It doesn't mean they must always be on a straight line. They can also be like this and they are adjacent because they have only one line between them. So angle M and N are adjacent. But if you look at angle X and Y in the third diagram, you can see they are not adjacent because there is a space in between them and there are two lines between them. Adjacent angles ought to have only one line. So I have one line here, another line here, then one line divide these two angles into two, then I will say they are adjacent. This definition is very important to you because it will help you in solving questions. So in real life situation, you can see adjacent angles. This and this are adjacent. This angle and this angle are also adjacent. This one and this are also adjacent. But we can't say this angle and this angle are adjacent. That is not true. But rather this and this could be adjacent. So we can also see adjacent angles here and there. If you open a book, you can see two angles formed, one here, one there, and you can create adjacent angles in a book as well. Sorry for that slide. The last aspect I want us to look at to end this video, which to me is quite lengthy. Currently we are even with 17 minutes so far. We want to look at the naming of angles so that we end with this aspect of the video. Now, talking of naming of angles, normally you see questions of this sort whereby they will give you a diagram. They won't put in any value in the diagram, but then they will give you the values with the names of the angles. Let's say angle PRQ is 58. Sometimes students find it difficult to locate the 58, where the 58 is going to be. If you can't locate 58 on this diagram, that means you can't even solve the question in the first place. So PRQ, which will be this angle, is 58. So questions of this sort demand that you understand how to name angles, and when an angle is named, where can we locate that particular angle in the diagram is very important. So we want to learn more about that. Angles can be named in three different ways. That is the form of writing it. We can write angles like this. For example, if I have this diagram and I have angle with the line AB and the line AD, we create angle. And this angle here, which is the angle marked here, can be called angle BAD. Or we can even say DAB. So angle BAD, that means we have the line BA and then AD. So that is where we have the angle, right? We can just write angle and write BAD, or we can use this symbol and write BAD. We can also write BAD and put the cap on top of the middle letter to show where the angle is. And because the angle is at A, the cap will be on A. So these are the three ways we can write angles. But in the naming itself, now let's see. How will I name this angle here? Okay, how will I name this angle? Now this angle exists between two lines here, the line B to C and the line B to E. And the two lines meet at the point B. And so we are going to name the angle and have B in the middle of that angle. So either I will say C, B, E, or E, B, C will be the result. Hope it makes sense. Now let's look at this angle too. Here we have two lines that are forming this angle. Line B to D and D to E. And for that matter, D must be in the middle of the naming because the two lines meet at D, and that's where the angle is. And so we can call it BDE, or we can call it EDB, making sure that the middle letter represents where the angle, the two lines meet. Now look at this one too. Now, how do we name this angle? You can pause the video and give yourself a try. Now, this angle exists between two lines. Look at the two lines. The line this one and the line that one. And the two lines meet at the point E. So E must be in the middle of the naming. So the line exists between B to E and then E to F. And so we'll call this angle BEF or FEB. Normally, we name angles in anti-clockwise direction, but for now, let's use the two sides. What about this one? Can you pause the video and name it? Good. I believe you had BDA. Sorry, DBA or ABD. That means they meet at the point B. So the line AB and the line BD. Then the last one. Good. So D to B, then B to E. So we call it DBE, or E here, B and D. Good. Now I'm going to give you a series of angles to name here, right? So each of them I'll give you the answer afterwards. So when I pop one, you pause the video, you say the answer, then you continue. I believe you had RSQ or QSR. QTP or PTQ. Be careful with this one. It exists between two lines. The line is here and that. So this line is QP and this line is PT. So I'm going to say QP then T. Good. So QPT or TPQ. What about this one? Okay, so that is QOT or TOQ. Check this one. Look at the line. Look at the angle from the line QR and QP. So how do we name that one? Beautiful. Okay, so far so good for this part of the video. I believe you've enjoyed a lot. This is quite lengthy. Our 23 minutes is quite lengthy. Thanks for watching this video. Let's meet on our next lesson.